Hi Precalc. So today we are finally going to start the meat of this unit. We're going to start looking at piecewise functions. All right, so let's look at these starting questions. So Miracle is driving to the supermarket, which is 10 minutes away and 5 miles away. And note it says at a constant speed. She shops for 10 minutes at the supermarket, and then she speeds back home at a constant rate again for 5 minutes. And we need to draw a graph of this. So this graph is supposed to show distance from home versus time. Note that time is on the x-axis because time is always the independent variable. All right, so of course we're going to start when time is 0. So let's put a dot at 0, 0. Miracle starts off at home, so that's where our first dot should be. Now, after 10 minutes, she's at the supermarket 5 miles away. So we can look at x equals 10 over here and distance of 5. We should put a dot over there. All right, she then shops for 10 minutes. So it's for these 10 minutes, she is still at the supermarket. So after 10 minutes, she is still 5 miles from home. So we're going to put a dot at 25. 20, 5, I mean. And then 5 minutes later, she is back home. She sped home. So after 25 minutes, she is home. And let's connect these dots. All right. I love this ruler. Then one last line. All right. Hopefully this graph looks kind of familiar, but we'll talk more about it in a minute. Let's look at the second part of the starter. How do we find the equation of a line given 2 points? This was yesterday's assignment. So if you have 2 points, let's say you have A comma B and C comma D. How are we going to find the equation of our line? So according to yesterday's assignment, you're first going to find the slope by subtracting these 2 points. So B minus D over A minus C, that will give you your slope. And then you choose one of these points. It doesn't matter. And then you're going to sub it into your equation of a line. So you remember equation of a line is y equals mx plus b. You do not know your y-intercept. This is a big question mark. But you have a y, you have a slope now, and you have an x. So we will sub in for those, and you will get your y-intercept. Get b, and then you will be able to write the equation of a line. All right, so we're going to use these two things in the next question. Oh, look, here's that graph again. Miracle's trip to the supermarket. So as you noticed from a couple of days ago when we were doing domain and range, you have this exact same graph. And we have a few different segments on this graph. And you couldn't write the equation overall for this function because it had different pieces. So let's look at each piece individually. Let's look at segment A first, which I labeled. Now, I want the equation of segment A. Segment A, notice, is a line segment. So we can write the equation as long as we know 2 points on segment A. Well, there are several points we know on segment A. You could choose, let's see, the starting point. We could choose the ending point. We could choose this nice point here. There's this point, this point. We have several points that we know on segment A, which means we can figure out the equation of segment A. So let's see. I'm going to choose 2 of these points. I always like 0, 0. That's always a great point. So we'll go with the starting point and the end point. All right, so 2 points, 0, 0, and 10, 5. Let's find our slope by subtracting these. 0 minus 5 over 0 minus 10. That's negative 5 over negative 10, which is 1/2. So there's our slope, and we can get our y-intercept, and we actually have our y-intercept in this case because we have a point on the y-axis. So this segment is a little bit easier than the other segments. So the equation of this segment, y equals 1/2 x, and our y-intercept is 0. So that takes care of the first half of this question. The second half asks, on what domain is segment A graphed? So remember, we know that there are different parts to this graph. So for segment A, what x values does it exist for? And we can see that segment A only goes from x equals 0 over on the green point. And I'm going to extend this all the way to the end of segment A, and it stops there. So that x value at the end here, that's x equals 10. Our domain is 0 is less than or equal to x is less than or equal to 10. All right, we're going to do this for the other sections as well, segment B and segment C. Segment B, again, we want the equation of segment B. Now notice, segment B is a horizontal line. So horizontal and vertical lines are actually a little bit easier because there should be some built-in equations that we know about them. The thing about horizontal lines, let's start it off the same way first. I'll use red this time. So we know several points on segment B, just like we did with segment A. And notice for all of these points, this first one, the coordinate is 10, 5. The last one that I drew in, that coordinate is 14, 5. Notice how the y coordinates are the same, and it'll be the same for all the other dots too. So any horizontal line will have the equation of y equals something. And in this case, the y coordinate is 5. So we have y equals 5. Segment B, just like segment A, is only valid for a certain part of this function. And segment B starts at 10, ends over here at 20. So the domain for segment B is 10 is less than or equal to x, less than or equal to 20. All right, one last segment, segment C. Let me zoom out a little so I could keep the graph. Yeah. All right, let me zoom back in. So segment C, and let's get that question in there. There we go. Segment C. All right, I will draw this in blue. Segment C is over here. And again, we have several dots in segment C, and I, again, will use the beginning and the ending dots. This is not a horizontal line, it's not a vertical line, so we don't have just like a y equals or an x equals. We'll have to use our old process. So the first and last dots, that's 20, 5 and 25, 0. All right, our slope is going to be 5 minus 0 over 20 minus 25. So that's 5 over negative 5, which is negative 1. Now we're actually going to have to go find our y-intercept because we don't have a point that crosses the y-axis. So I always like to use the points that have 0 in them if possible. So we have, y equals mx plus b, and I will sub in this second point. 0 equals negative 1 times 25 plus b. That means b is equal to 25. So now we have the equation y equals negative 1x plus 25. There's our equation, there was our second, and there was our first. We have 3 equations. And again, we need the domain. So our blue segment, it started at x equals 20. So 20 is less than or equal to x. and it ended at 25. All right, so we have equations and domains for each one of these. Now, this is a piecewise function. And think of the name piecewise. It really actually just means that a function has several different pieces, just like we can see with this function. Now, a piecewise function, we can write it all as one function, and we're going to see that below with number 4. But we really just put together all the different functions that made it up. So to write the piecewise, we're basically going to copy what we have above. For the first part, our equation was 1/2 x plus 0. And notice how there's this comma in the second space. For the piecewise function, you have to write, where is this piece of the function valid? And that's what the domain is there for. That's why we did the whole domain and range review. So here we have to write 0 is less than or equal to x, less than or equal to 10, because this equation right here is only valid on this domain. Second part, y equals 5, which is valid from 10 to 20. And then the last part, which is -1x plus 25, valid from 20 to 25. All right, so a couple more notes about a piecewise function. You see this curly bracket. You always want to put the curly bracket in front of all your pieces, because that shows that f of x is equal to every single piece here on the domains that we talked about. Now, the other thing is, notice how, let's get a different color. Let's get pink. Notice how we have equals to 10 up in this domain, but also equals to 10 over in this domain. We don't like to be equal to 10 in two different places, because let's say you want to know, oh, which function is valid when x is equal to 10. Right now we have two different answers. We could say, oh, this function is valid and this function is valid, because we have equals 10 for both of them. So it doesn't really matter which one, but you should erase one of those. So let's say I already used it up top, so I'll erase it in the second one. And then let me just fix that. And then we'll have just a less than sign. So this way, when x equals 10, we can look specifically at one part of the piecewise function. We will not look at both. Same thing happens for 20. So for 20, we can see that we have something here and we have something here. So I will erase the second one just like last time, and then we know for sure that 20 will just look at one particular function. All right, you have some final notes to copy down on the next page. I've already written them in, but we have the definition and the process for writing a piecewise function. Oh my God, what's going on? Hold on for a sec. All right, so a piecewise function is a function which is defined by multiple subfunctions, with each subfunction applying to a specific interval of the main function's domain. So basically it's a function with smaller functions, and each of these smaller functions are on a specific domain, just like we saw in our examples. Now, for the process, basically you follow these two steps. Here we go. For each piece, determine the equation and the domain. And I forgot the N on domain. There we go. Determine the equation and the domain for each piece. And then you write the equation for each subfunction in piecewise notation, which is this notation that you see down here. So you'll have the f of x equaling the bracket, and then all your pieces, you're going to write them over here with their domains. So just like we saw in the previous example, that is piecewise notation. All right, so you have the last couple of pages for homework. The questions should not take too long. Email me if you have any problems. Stay safe.